Okay, for what we have in the realm of working with substitution, and it looks like we're going to have a homogeneous equation, and if we isolate the derivative, okay, so we have y prime will be in reference to dy over dx. And I'm going to have x squared plus 2y squared all over 2xy. And if I look at separating, okay, so for x squared over 2xy, okay, that is going to be 1/2 of x over y, and 2y squared over 2xy, that is going to be just 1 y over x. And for what we have on the side, again, so we can assign a substitution variable since we have a homogeneous equation. So I can say that I have v is equal to y over x. And if I write this expression in terms of y equals, I have vx. And again, if I take the derivative in x of both sides, I have dy over dx is equal to, and again we have v times the derivative in x, which is going to be v times 1. So we have v, and I will have x dv over dx and for what we have, again, from the first equation, we have dy over dx is equal to what is going to be 1/2. Now for x over y, again, that is going to be the reciprocal of v. And for y over x, okay, that is going to be v. So we have in the rewrite, we're going to have that dy over dx is equal to 1 over 2v plus v. And we have the simultaneous occurrences going on for dy over dx. And looking at setting the statements equal to each other, and I would just have the derivative expression on the left hand side of the equation. So I have v plus x dv over dx is equal to 1 over 2v plus v. And if you notice, okay, if we combine v terms together, we will have the cancellation of v. So we have, with v going out, we have x dv over dx is equal to 1 over 2v. And separating the variables, so we're going to have 2v dv is going to be equal to dx over x, and integrating over both sides, we're going to have that v squared is equal to the natural logarithm of x followed by the constant. And considering that already we have that v is equal to y over x, I can replace v with y over x. So I'm going to have y over x quantity squared is equal to the natural logarithm of x plus c. And so we have squaring the left-hand side. So I have y squared over x squared is equal to the natural logarithm of x followed by the constant. And getting y squared by itself, and I can either leave an expanded or factored form, whereupon I can just say y squared is equal to x squared times the quantity of the natural logarithm of x plus the constant. Okay, so for what we have in number 4, we have x minus y times y prime is equal to x plus y. And if I go ahead and write y prime in Leibniz's notation, so I have dy over dx is equal to x plus y, and we will go ahead and divide by the binomial coefficient x minus y. And treating this as a homogeneous equation, again we had that v is equal to y over x, and once again we had that y is equal to v times x. So just taking what we have from the setup, so we have x plus vx and we have all over x minus vx and factoring out x from both the numerator and denominator. So we will have x times the quantity of 1 plus v all over x times the quantity of 1 minus v. And here we're going to have x's to go out. So dy over dx is equal to 1 plus v all over 1 minus v. And again, for y is equal to vx, again we'll have that dy over dx is equal to v plus x dv over dx. Okay. And so looking at what we have, setting things up simultaneously. So we have v plus x dv over dx is equal to 1 plus v all over 1 minus v. And looking at isolating x dv over dx. So if I take v away from both sides, again, so looking at subtracting v. And just doing a bit of backtracking, so we have 1 plus v over 1 minus v. Then we have minus v. And I'm going to rewrite v in terms of the denominator. 1 minus v. So we have consolidating. Again, from the first fraction, I have 1 plus v. Then we have minus v. And we have a negative times a negative is going to be a positive v squared. So for what we have, again, is x dv over dx is equal to what is going to be 1 plus v squared all over 1 minus v. Looking at separating, okay, so if I flip the right hand side, so we have 1 minus v all over 1 plus v squared dv is equal to dx over x, and integrating, so we have 1 over 1 plus v squared dv minus the integral of v all over 1 plus v squared is equal to the natural logarithm of x followed by the constant. Okay, so we now have for 1 over 1 plus v squared, so that is going to be the arctangent of v, and then we're going to have minus what is going to be 1/2 the natural logarithm of 1 plus v squared is equal to the natural logarithm of x followed by the constant. And if I look at back substituting again, so we had that v is equal to y over x. So we end up with the arctangent of y over x minus 1/2 the natural logarithm of 1 plus y squared over x squared is equal to the natural logarithm of x followed by the constant. Okay, for number 12, we have y prime is equal to y squared plus x times the square root of 4x squared plus y squared. And if we again look at isolating the derivative, so you have dy over dx, and we have is equal to y squared plus x times the square root of 4x squared plus y squared all over xy and upon reducing, so we have y squared over xy, so that is going to be y over x. Then we have x over xy. Okay, so that is going to be the reciprocal of y, and so we have the square root of 4x squared plus y squared all over y. So we have, applying the substitution variable v, we have v is equal to y over x. You have also y is equal to vx. And for both expressions, we have in terms of the variable v, we have dy over dx is equal to v plus the square root. Here we have 4x squared, and for y squared, that's going to be v squared x squared. We have all over y, and I'll just do a little bit of color coding. And if you notice, you can see we have dy over dx is equal to v plus, and if you notice, we have with x squared, for this radical term, so we have 4x squared plus v squared x squared. And if I factor out x squared, from the radical, so I have the square root of x squared times the quantity of 4 plus v squared. And that is going to be x times the square root of 4 plus v squared. We're just drawing this out, so we have x over y times the square root of 4 plus v squared. And guess what? V is y over x, so x over y is going to be the reciprocal of v. So we have dy over dx is equal to v plus the square root of 4 plus v squared over v. And once again, going back to y is equal to v times x, and we have once again expressing in terms of dy over dx, we have once again equal to v plus x dv over dx, and taking what we have for both expressions in dy over dx, and if you notice, we'll have the v's to cancel out, and getting what we have in v and x by themselves. Okay, so you have v over the square root of 4 plus v squared dv is equal to dx over x. And if we integrate over both sides, and if I were to apply u substitution, okay, we would have in the layout again, we have u is equal to 4 plus v squared, and du is equal to 2v dv. You have du over 2v is equal to dv. Have is equal to the integral of v over the square root of u, and for dv I have du over 2v, and for what we have in terms of following through, okay, so you're going to have 1/2 of the integral of u to the negative 1/2 du, and guess what? We have 1/2 times 2 times u to the 1/2 plus c, back substituting, and this is going to lead to the square root of 4 plus v squared followed by the constant. So reverting back to what we have here. Okay, so we had the square root of 4 plus v squared is equal to the natural logarithm of x followed by the constant. And if I follow through, so we're going to have the square root of 4 plus y squared over x squared is equal to the natural logarithm of x followed by the constants. And if I gather the terms together, and I'm just going to sort of restate here, so we have 4x squared plus y squared over x squared is equal to the natural logarithm of x followed by the constant. And what we're going to have in the lead up, okay, now the square root of x squared is going to be x, and if I multiply both sides by x, so we're going to end up with the square root of 4x squared plus y squared is equal to x times the quantity of the natural logarithm of x plus the constant. And another way that this could be written is to square both sides, whereupon we have 4x squared plus y squared is equal to x squared times the quantity of the natural logarithm of x plus c quantity squared. So this is another way that we can express the result.